Hi, hello there. Welcome to Number Systems video demo. This video is a supplementary video of the Number Systems video lecture. So I would recommend seeing the video lecture on number systems first prior to watching this video demo. So this video demo has been divided into two sections. The binary number systems, which will demonstrate how to convert binary to decimal and decimal to binary. On the second part of the video demo, we will be demonstrating hexadecimal number system, which covers hexadecimal to decimal and decimal to hexadecimal. So basically, there are different types of number systems, but this video demo covers only binary number systems, hexadecimal number systems, and the decimal number systems. All right, so let's get started. Binary number system. So to demonstrate, let me open and launch my Microsoft Excel here. So I'll be doing Microsoft Excel, okay? So for the demonstration of the number system. So let me start with the decimal to binary conversion. So from the video lecture that we had on number systems, we are given this algorithm or procedure here to follow to convert decimal to binary. So let's state first the algorithm. So start in the end position or the most significant bit. Okay, so is the decimal number of the octet n equal to or greater than the nth value? Okay, if no, then we have to record binary 0 on the end positional value and move to the next lower positional value on the right. If yes, then we have to record binary 1 in the end positional value and subtract positional value from the decimal number and move to the next lower positional value. We have to repeat these steps, okay, so through the first or the 1 positional value here. So we will be moving from the leftmost going to the rightmost. All right, so let's start with our first example here. So for instance, you will be converting 192 base 10 to binary. And if we are going to apply this algorithm here, so we could say, is 192 greater than or equal to 128 here? Okay, so the answer is yes. So therefore, if it is yes, then we have to place binary 1 here. All right, and then we have to subtract. So take note that the decimal given is 192 here. Okay, so that's 192 minus the positional value, which is 128. So minus 128 here, that would yield to 64. Okay, now the current decimal value is 64. Is 64 greater than or equal to the next positional value, which is 64? So they are equal. So therefore, we have to record binary 1 here. Okay, and then, so since that is yes, then we have to subtract the positional value, which is 64, from the decimal number, which is 64. And this would yield to 0. Okay, you've got 64 minus the current positional value, which is at 64, that would give us 0. Okay, now is 0 here greater than or equal to any of these positional values here? The answer is no. So therefore, we have to record 0 on all these positional values here. Okay, so until we reaches this 1 positional value. All right, so therefore, we could say that 192 is equals to 11000000 in binary. All right, so 192 is equals to 11000000 in binary. All right, so let's apply that on the second example here. For instance, we have 168. All right, so 168. So let's remove this and place 168 here. Okay, So following the algorithm, okay, is 168 greater than the recent or the most significant value here, which is 128? Okay, the answer is yes. So therefore, we need to place 1 here. All right, and then we have to subtract 168, okay, minus the current positional value, which is 128, and that would yield to 40. Okay, now let's move on to the next positional value here, which is 64. Is 40 greater than or equal to 64? The answer is no, and therefore we need to record 0 here. All right, we need to proceed to the next lower positional value, which is 32. Okay, now is 40 greater than or equals to 32? It is greater, so therefore we need to place binary 1 here. Okay, and then we need to subtract that 32, okay, from 40. This is 40 here minus the current positional value, which is 32. That would yield to 8. All right, so we are now on the 16th positional value. So is 8 greater than or equal to 16? So the answer is no. So therefore, we need to place here 0. Okay, moving to the next. So is 8 greater than or equals to 8? The answer is yes. If it is yes, we need to add a binary 1 here. Okay, so and then we need to subtract 8 from the current positional value, which is also 8. All right, so that would give you 0. Now, no values left, so therefore, we need to enter 0 in the remaining binary position. So this would be 0 here, 0, and 0. So therefore, 168 is equals to 10, okay, 10, and then 10, and then 00. All right, so that's how easy it is to follow this procedure. Now, to convert 30, another thing is, I guess this is much simpler. Okay, so to convert 30 to binary, so we just have to look on those values to produce 30. Okay. All right, so let's work on 30. So to get 30, we need 16. So we have to start on 16 because 32 is greater than 30. So setting 16 to 1 would yield to 16. Take note that we need 30. Okay, so if we have 16 plus 8, all right, so that would yield to 24. All right, and then we need another 4 here. So 24 plus 4 is 28. And to get 30, we need 2 more. Okay, so therefore 16 plus 8 plus 4 plus 2 equals 30. Then we just have to use 0 on those empty cells there. So that's 30. All right, so I guess that's much easier. Now let's try that on 20. Now to get 20, okay, so we have to start with 16. So 16, so place 1 there, and then place 1 on 4 because we need 4. So 16 plus 4 is 20. So therefore, the rest of the positional values here would be 0. All right, so we could say that 30 is equals to, okay, 0, 0, 0. You've got 1, 1, 1, 1, and then you've got 0. All right, so that is for 30. Now for 20 here, okay, so that would be, okay, 0, 0, 0, 1, 0, 1, 0, 0. That's 30, that's 20 there. Okay, so it's up to you whether to follow this algorithm here or the one I just recently demonstrated on the next two here. All right, so that's how simple it is to convert decimal to binary. So again, let me launch my Excel here. All right. So let's convert binary to decimal. So let's try that. So use positional value when converting binary to decimal. And then we just have to add the positional value where the binary bit is set to 1. All right. So for instance, we are given here the binary 11000000. Let's try to plot it on our positional values here. Okay. So this would be 1 1 0 0 0 0 0 0. Okay, so that is from the given here. All right, now to get the decimal equivalent of that, we just have to add, okay, the positional value where we placed 1 on it. Okay, so therefore you've got 1 here on 128 and 1 here on 64. So 128 plus 64, that is the decimal value of the 11000000, which is equivalent to 192. All right, so as simple as that. 192, that's equals to 110000 and 00. All right, so let's try the next one. So the next value is 10101000. So let's plot it here on our positional value. So that would be 10. All right, and then 1 0 1 0 and then 0 0. Okay, so again, using our procedure here, we just have to add or use the positional value and then add the positional value where the binary bit is set to 1. So take note that the binary bit is set to 32 and 128 and 8. Okay, so we just have to add 128 plus 32, okay, so which is 1, plus 8, which is 1. And therefore, this is equals to 168 there. All right, now let's have another example. So let's plot this 0101 1111. Okay, so 0 1 0 1 1 1 1 1. So what is the equivalent of this binary here? So take note that 0 is on 128, so we just have to ignore it. 1 is on 64, so let's have 64 here. Okay, plus 1 for 16, okay, plus another 1 for 8, okay, plus 1 for 4, okay, plus 1 for 2, and then plus 1 for 1. Okay, so therefore, this binary number 0101111 is equals to 95. All right, so let's take the last example. So this one here is 00101000. Okay, so let's plot it on our positional value table. You've got 0 0 1 0 1 0 0 0. All right, so again, we just have to look on those binary bit 1. Okay, so placed on 32 and 8. So this would be 32 here, okay, plus 8 here, and that is 40. So therefore, 00101000 is equals to 40. Again, that's how easy it is to convert binary to decimal. Hexadecimal number system. All right, so let's have the next demo, which is decimal to hexadecimal. Okay, so let's try. We need to follow the steps listed to convert decimal numbers to hexadecimal values. So first, you need to convert the decimal number to 8 binary strings or 8-bit binary strings. and then divide the binary strings in groups of 4 starting from the rightmost position. And then convert each of the binary numbers into their equivalent hexadecimal digit. Now, for instance, we are going to convert this 255, 192, 165, and 143 here, all decimal, to hexadecimal. Okay? So, let's do it. For instance, we have 255. So, let's start with 255 there. Okay? So, 255 in binary. So, let us convert first this into binary. So, if we are going to set all of these 8 bits here to 1, that's equals to 255. So, something like 128, okay, plus 64, plus 32, plus 16, plus 8, plus 4, plus 2, plus 1. That's equals to 255 in decimal. Alright, so that is the first step here. So the next thing is we need to divide these binary strings in groups of 4 starting from the rightmost. Okay, so therefore we simply copy this. Alright, so we have to group it. Let me place it here. Okay, or we could group that one. Okay, so you divide it into 2 groups. This is the first group, and this one here is the second group. Okay, on the first group, we need to place the positional value 8421 for every 4 bits. So 8421 for the first group, and another 8421 for the next group. Okay, and then afterwards, we need to convert each of the 4 binary numbers here to the equivalent hexadecimal digit. Okay, so 1111 is equals to 15 in decimal. In hexadecimal, 15 is F. Alright, so this one here is F here. So take note that hexadecimal here is not case sensitive. Alright, so 1111 is also equals to F. So therefore, 255 in decimal is equals to FF in hexadecimal. Alright? Okay, so let's try that on the next given. So which is 192 here. Okay, so 192, let's remove this one here. Okay, so let's convert that first into binary. Okay, so 192 is 128, okay, plus 64, that's 192. So that means the rest of the positional value here should be given 0. Alright, so 128 plus 64, that's 192. Okay, so we simply group this into 2. So this is our first group here. Okay, so let me just copy it. First group. Alright, and this is our second group here. Okay, second group. So again, for each of the group, we need to place or use 8421 positional value. Okay, so for the first group, that is 8 plus 4, and that is 12. Okay, so 12 in binary or in decimal is equivalent to C in hexadecimal. So this is 12 here, 8 plus 4 is 12, so therefore this one is C. Okay, next would be 0, 0, 0, 0, that's 0. So therefore 192 in decimal is equivalent to C0 in hexadecimal. So this one here is C0. Alright, so did you get it? Alright, so let's have another one. Let's say 165. Okay, so let us remove this. Okay, so again, 165. How do we get 165 from the positional value? So that is 128, okay, plus 32. Okay, so that's 160. We still need 5. To get 5, we need 4 plus 1, that's 5. So therefore, 128 plus 32 plus 4 plus 1 is 165. So we just have to place 0 on this empty cell here. So 0. 0 and 0. So again, we need to group this into two groups. So the first group, again, you place that on the 8421, and so with the second group. So next is to convert each 4 binary numbers here into hexadecimal. So this one here is 8 plus 2 is 10, and 10 in hexadecimal is A. All right. Next, this is 4 plus 1. This is 5. So therefore, 165 is equals to A5 in hexadecimal. Okay. So let's have the last one, 143. Okay, so let me remove this. Let's plot in 143. All right. So to get 143, so that should be 128. Okay, plus 8. Okay, plus 4. It's 140 plus 2. 142 plus 1, 143. All right. So therefore, these are zeros here. Okay. So 143 is equals to 1000 1111. Again, we need to group it. Okay. So group it into 4 bits each. So you've got two groups there. All right. So the first group would be 1000, and this is equals to 8. All right. And then 1111 here is 15 in hexadecimal, that's F. So therefore 143 is equals to 8F in hexadecimal. All right. So again, it's easier, right? So again, let's go back to our Excel file here. Let's have a demonstration of hexadecimal to decimal. Okay, so you just have to follow the steps here to convert hexadecimal numbers to decimal. Okay, so this is just the opposite of what we did with decimal to hexa. So convert the hexadecimal number to 4-bit binary strings, and then create an 8-bit binary grouping starting from the rightmost. Okay, and then convert each 8-bit binary grouping into their equivalent decimal digit. So let's try that. Let's start with 3D here. Okay, so 3D, so we have 3 here. Okay, and then D here. So to convert 3 into a 4-bit binary, so this would be 0 here. Okay, this should be 0 because to get 3, that is 2 plus 1. All right, so this is 3 here. Next, D is equivalent to 13. So to get 13, we've got 8 plus 4, that's 12, plus 1 here, that's 13. So therefore, this one here is 0. All right. So we already have our 8-bit binary. So we just have to copy this. Okay. And then let's get the decimal equivalent of that. Okay. Now to do that, so you've got 32 plus 16 plus 8 plus 4, that's 60, plus 1, that's 61. So 3D here, 3D hex is equals to 61. All right. So simple, huh? Okay, so let's have another demo here. CE, another example. So let me remove this. So again, we have hexadecimal digit C and E. Now C is equivalent to 12. So to get 12, that is 8 plus 4. All right, so that's 12. So these are 0, 0. To get E, E is 14. So that is 8 plus 4 plus 1, that's 14. So this one here is 0. Okay, so therefore, we have already an 8-bit binary grouping, so which is 1 1 0 0 1 1 1 0 from this binary digit here. Okay, so again, we just have to add all the positional value having a 1, okay, binary bit there. So that would be 128 plus 64 plus 8 plus 4 plus 2. That would give us 206. All right. Next, let's try 9F. Okay. So what is the equivalent of 9F in decimal? So let's have 9 here and F here. All right. So 9 is 8 plus 1. That's 9. So therefore, these are 0 here. F would be all ones. All right. That's 15. Okay. So of course, we need to group this. Okay. And use that. All right. So to get 9F in decimal, we simply add 128 plus 16 plus 8 plus 4 plus 2 plus 1. That is 159. Okay. Next, last one, EA. So we've got EA here. All right. So E is 14. So to get 14, 1, 1, 1. That's 14. This one is 0 here. To get A is 10. So that is 8 plus 2 here. That's 10. So therefore, these are zeros. Okay. Now the 8-bit equivalent would be, all right, so this is 1, 1, 1, 0, 1, 0, 1, 0. Okay. And then add this 128 plus 64 plus 32 plus 8 plus 2. That would yield to 234. All right. So that's the conversion of hexadecimal to decimal. Thank you very much for watching and listening. I hope you have learned something new from this video demo. Have a great day.